So it's my great pleasure to introduce tonight's plenary speaker, Professor Tim Hatton. Tim is professor at Essex and also has an appointment at Australian National University. He's worked on a variety of economic history topics such as interwar London labor markets, migration, and health and heights. I've been told to keep this quick, and so let me turn over the microphone to Tim.
Thanks very much, Andrew. Thanks very much, Andy, and thanks to the organisers for inviting me to give this talk. And let me thank you all for coming as well. I realise that I'm keeping you away from conviviality at the bar, and so I promise not to drone on for too long. So that's the first thing. This is all about heights and the long and the short of it. Hopefully it'll be short. So there's a long tradition of work on heights in history, and I'm a latecomer to that literature. And I remember when I was much younger than today, 30, 35 years ago, when the heights literature was just sort of taking off, thinking and saying to people in my kind of youthful cynicism, oh, this is a fad, it's not going to last very long, and anyway, where's all the data going to come from? It's just a flash in the pan. And I wasn't very good at forecasting then, and I'm not very good at forecasting now. I've got colleagues at Essex who are from other parts of the world, and they ask me about British politics, and I say to them things like, well, the Liberal Democrats will never form a coalition with the Tories. I say Cameron won't win the election. I say the Brits will never vote for Brexit. So, wrong every time, right? I am really glad I did not become a political scientist or a treasury forecaster. Economic history seems to be the right thing for me. Forecasting the past is a lot easier, I think. That's why I'm doing it. So, when I came to sort of catch up on this literature, I read the early classic works by pioneers like Bob Fogel, Roderick Flood, Rick Steckel, John Komlos. And it was sort of interesting to read that literature because in the early literature, height was being used as a sort of a proxy, another measure of income, because people were so unhappy with real wage statistics and things like that. And you can see how the literature has evolved, because I think one lesson from the debates which followed on from that is that height and income are not the same thing. They don't sort of follow each other in lockstep or anything like that. Nowadays, I think in the recent literature, we think of height as being more an indicator of health in early life, and that's the way I'm going to think about it in this talk. But it's interesting that the focus on the 18th and 19th centuries, which was what this literature did, has to a large extent endured, less so in the last decade perhaps. And yet, when you look at some of the statistics, what really sort of hits you in the eye, or hit me in the eye anyway, is that for all the debates about the 18th and 19th centuries and so on, the most spectacular increases in average height came in the 20th century, and that's not what people were looking at. There is economic history literature which comes up to 1914, maybe a bit in the interwar period, and there's another literature written by epidemiologists and people like that who are interested in much more recent data, but there's a gap in between. And that's really what's, I think, recent studies and papers, not just by me, but by lots of other people, have sought to fill in. And when you look at that, you see that the long-run trends of the 20th century are quite striking. We know that death rates fell, life expectancy increased, and so did heights. So one sort of step in my little adventure with this was to put together a data set of heights of males aged around 21 for 15 European countries by 5-year averages. So from 1850-60 to 1976-60, those are the birth years. And just to give you a sense of what this data is, the post-1950 data mainly comes from cross-sectional surveys, so we use height by age to sort of plot back different cohorts. And then, given that we don't have that for earlier years, we're using conscripts and army records to kind of take it back to the middle of the 19th century. So when you do that little exercise, I should say other people have done much more than this. Jörg Barton has a much bigger data set with more countries, more periods, but the subset of his data that I'm looking at here is pretty much consistent with what he finds. So there's some consensus on these numbers. Okay, so when you look at these 15 European countries, if you look at the birth cohort of the early 1870s and compare that with the birth cohort of the late 1970s, in other words, just over a century, the increase in adult heights is about 11 centimeters. It's 4 inches in old money, right? I mean, that's a big number in my view, and something that deserves to be thought about a bit more. I should say, it's, before I get to that, I should say that, I mean, if you compare that with, now we've got much wider and longer data, it's unprecedented in earlier periods. There's no period where over 100 years you get an increase of 10 or 11 centimeters. So it's really unprecedented. Okay, this is just to remind you that we only, when we're using height by age, we only use men or women, this is men, age 20 to 50, because we're worried about growth at the beginning of the life cycle and decline at the end of the life cycle, and that's what this says. And I am very sad to tell you this, but if the survey was done today, even though I look young, good looking, tall, I wouldn't be in this, right? Because I'm over 50. Believe it or not. Here's what the data looks like. It's a bit sort of bumpy, but that's what it looks like when you put these numbers together. You can see that these are the 15 European countries down on the right-hand side, different colors if you can make them out. But you can see there's a sort of range of countries in terms of the levels, and then a general sort of upward trend from the middle of the 19th century onwards. And if you sort of divide these countries into 3 groups, for example, taking the North Europe, Scandinavian countries, UK, Great Britain, I should say, and so on, and then Middle Europe, and then Southern Europe, you do find a few differences. So for all these groups, heights were increasing at about 0.8 of a centimeter a decade from the early 1870s cohort to the 1911 to 15 cohort. And then in Northern and Middle Europe, we see an increase in the pace to 1.4 centimeters a decade from 1911-15 to 1951 to 55. So that's a distinct upward tick in the rate of increase of heights. And that sort of surprised me, really, because, you know, this is a time of 2 world wars, the Great Depression, all those traumas and so on, that you wouldn't think necessarily it was going to be a time of rapidly improving child health. It predates the miracle drugs. It predates National Health Services and all that jazz. So you wouldn't really necessarily have thought that was going to be a spectacular period for improvements in health. If we go to the post-war period, what we find is that there's a bit of a slowing down in North and Middle Europe and an acceleration in Southern Europe. So that's roughly what those numbers say if you kind of analyze them that way. Okay. Right, so the thinking nowadays, I guess, is that we think of height as, you know, a summary, one of the statistics that represents health during childhood, which we know is determined, of course, they're genetic and all those issues, but as far as the outside influences are concerned, nutrition and disease are the key influences. And sometimes it's possible to measure those a little bit more directly, and I'll come back to that in a minute. But underlying those things are socioeconomic conditions which condition how much food people get, how much they're exposed to disease, and so on during childhood. What I've been keen to do is to try and sort of isolate the effects of the household, socioeconomic circumstances of the household, the individual children in the household, and the locality outside the household, and I'll come back to that in a minute. If you want to do this sort of thing, then you have to turn to micro data, unlike those broad aggregates I show, or broad averages I showed you just now. I'll turn first to the survey that was taken by, or led by Sir John Boyd Orr in the 1930s, a pioneer of studies of health and nutrition. And he and his team went around the country in what was then called a shooting break. And they went to Scotland, they went all over the place, a little group of people, measuring school children and taking other data from these kids at school. They covered nearly 3,000 kids altogether. These were aged 2 to 14, so there were school-age children. School leaving age was 14 in the late 1930s. And these were relatively poor families. I mean, they are, by relatively poor, I mean that their average income per capita was just about on Roundtree's 1936 revised poverty line. So they're not typical of families in Britain. But if you're interested in the poorest, then that's a very good data set to look at. So I worked on these a while ago, and some of the results, two key results I want to mention first are that if you run a regression on these heights, what you find is that household income per capita has a positive effect, no great surprise there. But perhaps more interesting is if you take that cross-sectional estimate and you then look at how working class household incomes per capita changed between 1906 and 1938, when we have the surveys to measure that, that would account for an increase of about 1.9 centimeters over the whole period in height. So that's quite a big effect. Income matters a lot because it's the way in which more food is provided for the family. Interestingly, there's also a separate effect for the number of children in the family. Now, it's not so, in other words, the number of children in the family is having an effect through diluting family income, more mouths to feed from the same income, but it's also having a separate effect and a negative effect in addition to that. And if you take into account the fact that families become smaller between 1906 and 1938, it's working class families again, then that would increase heights, according to this measure, by 0.7 centimeters. So that seems to be, if you're willing to map cross-sectional results into changes over time, that's what you get. That's quite a significant contribution, I think. Now, here's a household. This is one of the Boyd Orr households in Dundee, in an attic room in 1938. And you can see this is a family of 9. So here's mum, here's dad over here, and here are the kids. 1, 2, 3, 4, 5, 6, 7. So that's 9, right? That adds up to 9. I was really puzzled when I saw this, because look at this one here. I thought, even my regressions don't predict that, right? This is a very, very small child. Right? I couldn't believe how small this child was. This is, once you get to 7. So I conducted further forensic research on this picture and have discovered that actually that is a doll. Oops, that's right. Right, let's just press the right button. That is the 7th child. Right. Okay. So now, if you take these effects together and you look at how much that accounts for, I've already said 1.9 centimeters, 0.7 centimeters. If you add those up, then that accounts for about 2/5 of the increase in the height of the average 8-year-old between 1906 and 1938. So that seems like a substantial effect and a substantial contribution to the total increase in height. We can drill down a bit further than that, because if you just say, okay, income and family, and a number of kids in the family, okay, there's other things underlying that, food consumption, for example, the overcrowding of the dwelling, the cleanliness of the dwelling, all these things were mentioned by contemporary analysts and commentators as being important in determining the health of children. And we can do that with the Boyd-Orr data, and these things matter in exactly the way we would expect them to. One interesting thing in particular is that overcrowding matters a lot, numbers in the family matter a lot, in addition to per capita income, and that sort of suggests that the disease environment's important. More kids crowded into smaller spaces is going to spread disease more rapidly and more widely. And so if we look at the incidence of certain illnesses, which you can look at in the Boyd-Orr data, that seems to be one of the things that's happening. More kids are more often suffering from colds and infections and eye infections, ear infections, anemia, all these sorts of things, according to what the per capita income is in the family, and in particular, how many kids there are in the family. Another thing we can look at with the Boyd-Orr data, which fascinated me at first actually, was birth order. And the reason for that is that we have several children in many of the families. Some families we only have one child, but some of them we can look at lots and lots of different, or some different children in the same family. And that enables us to look up across the birth order and see what effect that has on health. And the result, when you do that, you can use fixed effects for families, just looking across siblings in the family. You find that height declines as birth order increases, which is kind of consistent with the idea of growing scarcity of resources in the family as more and more kids are born. We have to be careful, though, and this is one of my sort of hobby horses, to make sure that we don't conflate family size and birth order, because they're naturally correlated. You can't be birth order 5 in a family of 3, right? So you've got to either do these things separately, which is what I'm doing here, or make some adjustments to make sure, if you're estimating them together, that you don't conflate the two things. Now, I thought the Boyd-Orr data was quite interesting, gave some interesting insights into health of children in the 1930s. One thing that's difficult to do with this data is to really capture the locality effects. And there are 14 locations, there are bizarre sorts of places. I mean, so it's not really possible to do it with the Boyd-Orr data, and I want to move on to that. Now, what is the local disease environment going to look like? We know that infant mortality fell very steeply in England and Wales from just about the turn of the century. Child mortality had been falling before that, more gradually. But there's a lot of, there's a literature that regresses height on infant mortality as a sort of rough proxy for the disease environment. What some analysts have argued is that actually local mortality among children has two conflicting effects, infant mortality in particular. One is that if you have very high infant mortality And those that survive are the sort of fitter and likely to be taller, then higher infant mortality will lead to taller people on average, right? The selection effect. This idea was sort of popular briefly popular, I should say, among the eugenicists such as Carl Pearson, who argued this case quite strongly. The other effect is the scarring effect. That is, we think of infant mortality or child mortality as a sort of proxy for the disease environment in which kids are growing up. And that means that, you know, if they're going to be suffering from repeated infection, which this is a proxy for, then that's going to have a negative effect on height. This point was argued by Arthur Newsom, who was the medical officer of the local government board in several reports which subsequently became famous. I think, well, as I shall say in a minute, I think Newsom was right. So, in order to try and sort of address this question about scarring or selection of scarring, I took Bernard Harris's data on children in school in 20 towns by age and sex as well, between 1920 and 1950. And this test says that we're going to think about the selection effect as the effect of infant mortality in your town in the year you were born, right? We're going to think of and so that's weeding out, if you like, some people in that particular cohort. Right? The scarring effect is going to be captured by the infant mortality rate in your town when you're not an infant, but when you're 2 to 4, right? That's going to capture the scarring effect. So it's a simple horse race between these two variables. And guess what? The scarring effect dominates easily. In fact, there's no selection effect. I can't find any selection effect at all. So it's not a big surprise, I guess. If you look at these effects, then what you find is that for 6 to 9-year-olds, the fall in infant mortality between 1901-5 to 1941-5 is worth about just a bit over half a centimetre a decade, which is about a quarter of the total increase. So that's quite a big effect. And so the fall in infant mortality or child mortality, which we can see across the first half of the 20th century as a proxy for the disease environment, that seems to be important. Okay, so let's see if we can do a bit better than that. Now, adult heights. These three gentlemen are comedians. They will be known to some of you of a certain age who watch TV. And they were interviewed about their family backgrounds. And they were asked, how many siblings they had and, what it was like at home and all that. And this gentleman on the left is John Cleese, who's kind of upper class, as you can see, with his bowler hat on. And he said, well, mum and dad, mother and father, mater and pater, actually, what he said, had only 2 of us because we didn't want to split our estate up too much. So the middle one, who's got a trilby on, that's Ronnie Barker, who was supposed to be middle class, said, well, my mum and dad, we had 3 children in our family. Mum and dad stopped having kids because they said, well, 3's enough, and the price of potatoes is too high, we can't feed anymore, so we'll have to leave it at 3. Sorry, that's it. Ronnie Corbett on the right, you see, with the cloth cap on, supposed to be working class. He was asked about his family, and he says, well, mum and dad had 5 kids altogether, and there was 5 of us all crammed into a single bed, and it was a bit tough. And he said, but Mum and Dad stopped having kids when they found out what was causing it. Okay, so adult heights. First World War servicemen. What we're looking at now is whether the sorts of effects we've observed in the Boyd-Orr cohort for kids, how and whether that persists into adulthood, and whether we can also, in addition to that, capture locality effects. I'm doing this work with Roy Bailey and Chris Inwood, and we have collected some data on a sample of servicemen entering or enlisting in the British Army around the time of the First World War. We've got 2,236 servicemen in this data set who were born in England and Wales in the 1890s. Now, if you look at the number of men born in the 1890s and you look at the number of men of that age, push forward to 1914 to 18, I reckon about 2/3 of all the men in that cohort ended up in the army. So, or in the services, I should say, not the army. Most were in the army, actually. So, it's pretty representative. We're capturing, a vast bulk of, or we're sampling from what is the vast majority of men of that age. We miss some at each end of the height distribution, I think, basically because some of the least fit did not join the army or were rejected from the army, and we don't have officers, and they're a bit taller. So both ends of the distribution are a bit attenuated. What we've done is to find these servicemen in the 1901 census. So we first of all find them entering the army from their attestation form and their medical examination form, and then we search for them as children in the 1901 census. One of the things that enables us to do that with a reasonable amount of success is the fact that we know quite a lot about them. For example, who their next of kin was, which is usually a parent, because these people are generally single, and so it's easier for us to track them in that way. So we solve the John Smith problem by, John Smith problem is, of course, there are many, many John Smiths. If all you know is that somebody's name is John Smith and they're kind of 22 years old, then you've got no chance of finding them. But we have enough other information that we can actually find about 85% of them. So what do we get then? So we find the same result we got in the Boyd-Orr cohort, and that is that the number of siblings is negatively correlated with height. It's a bit smaller effect for adults, not surprisingly, somewhat attenuated. We find that if the household head is middle class, that means class 1 or 2, that adds about 1.4 centimeters to the height of this child, as we see in the 1901 census, but adult coming into the army in sometime in the First World War. Now, these are sort of, we find that persons per room has a negative effect. So these are sort of income-related variables. When we take these things into account, all the household variables that we can derive from the census, we found that infant mortality in the registration districts, so there are 635 registration districts in England and Wales, so quite a lot of them. They're quite small units then, much smaller and more distinctive than counties. And we find strong effects coming from the locality, even when we control for everything we can in the household. So it's not just that locality effects, which have often been used as a proxy for the average household in this particular location. It's not that that once we capture those individual household effects, we can wipe away locality effects. There is a distinct locality effect which over and above the socioeconomic circumstances of the household. One of the sort of striking things that we found in that exercise was that if you have just a dummy variable for an industrial district, that has a huge effect, 2.5 or 2.2 centimeters. How do you explain that? We know that there's a big literature for late 19th century England and Wales on sanitation and the reforms and germ theory of disease and all the rest of it, and sanitary reform is seen as important. Jonathan Chapman in last year's conference actually did a paper showing that sanitary reforms in densely populated cities reduced infant mortality and presumably also increased height. We don't know that yet. But less noted than that is the atmospheric pollution that was common in 19th century cities. And we've been looking at that recently for the First World War servicemen. Brian Beach and Walker Hanlon have done a paper on infant mortality, or on mortality, not just infants, looking at this, and we have done something similar to look at the heights of these servicemen. It's very difficult to measure pollution directly that far back in time. If you look at, there's some indicators which sort of suggest that if you think of just black smoke, which can be measured on paper and so on, that it was 50 times higher in the late 19th century than it is today. Right? What that means exactly is not so clear. There are other measures which suggest that, for example, looking at the characteristics of the air, that the improvement may have been even greater than that. What we've done, same as Beach and Hanlon did, was to construct a measure of coal intensity of each district, registration district, based on the occupational structure of the census. So we combine data from the 1907 Census of Industry, which gives us coal consumption by 139 industrial groups, and then we map that into the occupational structure of each registration district. So that gives us a proxy, a coal intensity measure for each registration district. And then the question is that what matters? This is Widnes in the late 19th century, which was a glass-producing area just east of Liverpool. And you can see what it was like there. And it was like this in many towns. Here's the map of coal intensity, our measure of coal intensity. This is by quartiles, so the darkest areas are the highest quartile in terms of coal intensity. And you can see it's sort of a map of the Industrial Revolution, roughly speaking. It just picks out those areas which are industrial all the way through the north here, down to South Wales coalfield, and then a little bit down here in London and Kent. I should say that we're measuring coal consumption, not coal production. So the only sense in which a coal mine is important here is if it's consuming coal, not if it's actually producing it and selling it. That's what it's intended to be. So what do we find? We find that there's a strongly negative effect on the heights of these servicemen. And if you sort of look at the different regions across England and Wales, so if you take, for example, the 10th to the 90th most polluted areas, according to this measure at least, that accounts for about 2.3 centimeters, a bit less than an inch. Now, you may say, oh, well, that's all very fine, but, this is just a proxy. We're not measuring emissions from coal use directly. How do you convince people that this is what underlies it? Well, one thing you can do is to say, okay, we know the wind is southwesterly. That means it comes from the southwest, not that it's going to the southwest, right? And so we should find that pollution or coal intensity to the southwest matters, coal intensity to the northeast does not matter. And that's exactly what we find. You may also worry that it's because these people somehow are, these people in these heavy coal use occupations are somehow different from everyone else. So we say, okay, well, let us measure the coal intensity of the individual household head's occupation of the child who became the serviceman, right? That has no effect at all. It is a genuine locality effect, not an average household effect. And, we tried to pin down the channel of influence by using instrumental variables analysis, where we say, okay, let us see if we can find this effect working through our proxy for the disease environment, which is child mortality from respiratory diseases, right? So first of all, you run a first stage regression on respiratory diseases and then use that as the instrument for your second stage. And so that's what, and that seems to work. So we're reasonably confident that that is the channel that is accounting for it. Okay, I'm not going to go on too much longer. Long-run trends. So this is going back now to the aggregate data for the 15 countries I showed you earlier on, and this is what the fixed country effects analysis suggests. These are the contributors to, or the main contributors to increasing height in these three groups of countries. You can see that, in particular, you see that in the 1911 to 15 period, the infant mortality effect is very large relative to these other effects. So that's when the disease environment is improving very, very strongly. One interesting thing about this, though, is that if you add up all these effects, I can't capture everything in country-level data, of course, but if you add up these effects, you get about 2/3 of the increase between 1871 to 5 and 1951 to 5. So if you take out infant mortality as a sort of, umbrella measure of the disease environment, and you try and capture that with underlying variables that somehow drive it, you'll capture less than half of the total increase. So there's stuff still to be explained that we don't capture with these variables. We don't, at the moment, have a proxy for the change in environmental pollution and so on, but you kind of think that comes after the Second World War. But I think one of the big missing things here is the growth in popular knowledge of nutrition and hygiene. And these were things which people were learning about from the late 19th century onwards, and which had important effects on the ways in which families, mothers in particular, brought up their children. Greater awareness of the importance of nutrition and of hygiene. So this is from a newspaper archive search for British newspapers, and it sort of shows the frequency of these two terms in the newspapers. This is standardized by the number of newspaper days, so it's sort of comparable over the period. And what you can see, I was kind of surprised by this because nutrition peaks in the 1870s. I was expecting it to peak a bit later, but the thing which sort of is really striking, I think, is how hygiene goes up and peaks in the 1930s. That seems to be kind of consistent with the notion that the disease environment's improving rapidly. People are learning more about it and how to deal with it. This is nutrition, and you can see that this is from a British Medical Council research study where they were concerned with telling people how important nutrition was for kids, and they conducted a feeding experiment supplementing kids' diets with certain foods, and this is the comparison. You can see milk wins, right? So this is the child whose diet was supplemented with milk. And you can see the other things don't do. So sugar does sort of alarmingly well, right? I mean, I don't really want to show this to the authorities today because they wouldn't like that. The thing that really struck me about this, though, is that this is the person with no extras, right? There's no supplementation at all. If you look at the guy standing next to him, right, if there's one thing I would like you to take away from this lecture today, if you've got young children or you're thinking of having them, don't give them watercress. So here's the conclusion. I've been looking at heights at the micro and the macro levels. I'm very struck by the dramatic increase in height with a notable acceleration over the first half of the 20th century. We can see at the micro level socioeconomic variables working through the channels of nutrition and disease. And I think one contrast with sort of the literature going back to the 18th and 19th century is the focus here on improvements in the disease environment, which not necessarily focusing only on or mainly on nutrition. And we see that particularly in the household, but especially in the locality. So at the local level, sanitation and pollution matter a lot, and improvements in those elements, I think, are a big contributor to the improvement in height and health in the first half of the 20th century. There's also the revolution in the application of knowledge of nutrition and hygiene. I think that's important, but so far we haven't been able to measure it very well. And that's it. Thank you very much for your attention.
Just talking about the disease environment, and you mentioned mining activities, coal activities. I remember it was Bob Vogel who also mentioned the fact that horses, and especially horse manure in big cities, was also had detrimental effects on children. Yeah. Maybe you could expand on that a little bit.
Yeah, so in the interest of being short, I won't expand on it, but because I haven't got any direct measurement of that. But what I think is important, and there have been a couple of studies on this, is it's not just the horses, it's the streets being paved, it's the getting rid of the chickens and the pigs from backyards. This whole cleanup, I think, is important, and just getting rid of all that. I think you're absolutely right to say, it's not just sort of human excrement that we need to worry about. It's all these other things going on as well. So I completely agree with that. I wish I could measure it. Well.
As far as I understand, there's these studies out there which link lead contamination with impact on children's and people's IQs.
Yeah.
What do you think that's just kind of like one example, or what do you kind of say that like the impact your environment, your genetics have on your height would also have a strong correlation with impact on people's IQs?
I imagine it would. I mean, as you know, there are, this is a big area in research among health economists now, looking at cognitive skills and other aspects of people's well-being. And these guys can actually measure this, right? Which we economic historians can't really do unless we suddenly discover a treasure trove of data to do it. But all the evidence points to pollution leading to lower cognitive ability, lower wages, less education, or less achievement. All those suite of things seem to be affected by atmospheric pollution, even at the relatively low levels of developed countries today. When you go to developing countries, where China and other countries, India, where there's a lot of heavy pollution comparable to the late 19th century, then you find it's even stronger there. Yeah.
Yeah, you mentioned overcrowding. I wondered to what extent mass suburbanisation in the 20s and 30s would have played a role, because that includes healthier environments, more space, better hygiene, gardens, a number of things which may have had cumulative effects, which may even have been more than the sum of the parts.
Yeah, no, I think your that's a good point. I mean, more than the sum of the parts, I think, is an interesting question, because most of the studies, mine included, sort of are linear regression. So they add things up, linearly. They don't actually account for possible interactions between, you can imagine, for example, nutrition and disease are not necessarily unrelated, right? I mean, you can imagine that there's an interaction effect between those two things, and I think overcrowding is one of them. So you can imagine that might be interacting with other things, and as you say, improvement. I think it's not just sort of less overcrowding with the modern building of the 1920s and 30s, but it's the improvement in the quality of the dwelling. I mean, in the Boyd-Orr cohort, we found that one of the things that really was kind of important in determining the heights of these kids was an assessed value of the quality of the dwelling, right? So just the sort of, whether there's damp or whether the walls have got gaps and all that kind of stuff. This is what the people conducting the survey did. They just gave an assessment. That matters a lot, right? So it's not just number of rooms, it's the quality of the dwelling, I think, that matters as well.
Hi, Tim. Hello, my name's Tony Milne.
Oh, sorry.
Hi,
Right,
okay. I'm an scholar, and I'm interested in one of the graphs that you showed that highlighted the different countries, the heights of different countries. Today, I think Holland is well known as being the country with the tallest people. But your graph showed that hasn't always been the case. Have you got any comments to make on what's happened there and how they've achieved that?
Yeah. To be honest, I'm not sure I do have any comments on that. I mean, the Dutch have a very kind of healthy diet with a lot of milk and stuff in it, don't they? What's happened in the Netherlands has also happened in Scandinavia to a large extent. It's not just the Dutch. Actually, when the paper that did this came out, there was a bit of a flurry of excitement about it, and I got interviewed by 16 local radio stations, and one after the other, and it was amazing. So what these people, they had two main questions, and that is, how tall did I think people were going to be in 50 years' time, right? I said, economic historian, not forecaster, no. And the other one is, did I think airline seats were too small? And so I'm a bit reluctant to sort of make these leaps of faith, actually, about things I haven't really studied properly.
We have time for one more question.
Tim, if you replaced height with life expectancy, would you expect to find the same kind of results, in that height is just one of many outcomes from this process?
Yeah. I mean, it is clear, I think, that, I mean, I haven't done that, so I can't tell you what the result would be, but it is clear that these variables are trended together. We can see in the first half of the 20th century a big decline in deaths at all ages from infectious diseases before, the deaths from diseases of old age really kick in. So, and that's really consistent with the profile that we see in heights, I think. So it is all of a piece, and I mean, I'm just looking at heights because everybody who's worked on, well, not everybody, I mean, people who've worked on demography for a long time, all we really got about health is death, right? And the good thing about heights is so the great thing about heights is it's not death. Right.
On this note, I think we'll close and thanks to our speakers.